Alrighty, last time we talked about distance fields. Let's go back to lit mode, just so that we can see all of the beautiful materials that we've made so far. Today we're going to be talking about one specific node that I just want to show off real quick, and that is the texture variation node. Because let's just make a new material real quick, and we'll call this texture variation, something along those lines, and I'll just use a texture sample, and we'll just use the included grass texture that we have on the base color here. So if we just do that and we put that material on here, we're going to at some point see a little bit of tiling. So if we use some texture coordinates here for the UVs, we've gone over all this in previous videos if this is going a little too fast for you. So let's just like tile that by 10 times, and you can start seeing a lot of tiling going on here, which isn't ideal, especially if you're using this for like large open worlds and such. If you're using specifically like grass, you're going to be seeing a lot of it on like a very like big landscape. You're gonna see tiling when you look at it from like above, which is not great. So that's where texture variation comes in, because Unreal, being a game engine, they thought, hey, this is going to be an issue, so let's make a texture variation. And there's a lot of inputs here. We're not really going to care about that. It's going to influence your UVs. So we want to put it in here. So we put in the UVs. Then we can put in like a variation scale, variation levels, like height map influences, masking channels, whether or not we want to like mask on any of these channels. To use dithering, which is, I think I showed that before, which is kind of like fading out in a cheaper way than using opacity. So feathering the patching that it's going to be doing. After all that, you can double click on this, by the way, to see all of the math that it does. It's quite a lot, so we're not going to go over that because, quite frankly, I don't fully understand it, what it does. I know what it does roughly is it takes UVs and at like somewhat random places, it just like rotates and scales things a little bit to create texture variation. Again, it does it on the UVs, so you can just put this into the texture sample, and now if we apply this, we can see that it's a lot less tiling. We still can see a little bit of tiling, and that is where the like variation scale and variation levels come in. So they have default values, but of course we can pull in some values of our own. Let's actually just put this on a cube so we can see it a little bit better. At the moment they're set to 0, so this is just like the default UVs. I think the default for them you can hover over, so that's 3.24 and 6. So if we set this to like 6 and 15, it's going to be a lot more varied, and you can see we don't really have any tiling left over anymore. We're not going to worry about the height map thing, frankly, because I don't think altogether it's entirely worth going into too much. For the most part, you're just going to be doing stuff like this. I do want to show you how to implement these things if you wanted to, though, because the height map takes in a texture to the object that's not just a texture sample. You can't just put a texture sample into this. This is quite important to understand. If you need to supply a texture to like one of these pre-existing nodes, what you do is you put in a texture object instead, and those you can plug in there, and you can still pick any texture you want. So let's just like go for the noise texture that we have, so like low blur noise texture, something like that. Anything that you want you can put in there, but it needs to be a texture object which just like puts in the texture directly rather than converting it to RGB data. So you can, what you can't do here is like add some cheap contrast to this, because it's just RGB data. You can't do that coming off of a texture object node. So it's a little bit more limited. Going into a texture object node, you can see we can output like a bunch of different types from the texture that we input. For the most part, we're just going to use color. But again, I don't really care about using the height map here. Just wanted to show you that, hey, if you run into a node that requires a texture input, it's likely going to need a texture object instead. We have a height map influence, which of course is the influence of the height map. If you put one in, we can mask channels. What I want to show you here is the dithering, random rotation and scale, and edge comparison. These are bool values. So we can just make a static bool here, and we can plug those into there. And that'll give us the possibility to say, hey, we want to apply random rotation and scale to this, yes or no. Because just look at over here. Right now, it's applying random rotation and scale, and if we turn that off, there is like the slightest difference. Things aren't being warped as much. Which might be a good thing if the texture you have, you don't want to rotate and scale them, you just want to like scatter them randomly. Use dithering. If we turn that on, the edges become a little bit less obvious. With this texture, actually, it's quite easy to not use dithering. So if you don't have to use dithering, you probably shouldn't, because it does take some extra instructions. Which is actually probably a good point to talk about that, because this is a short video otherwise. Anyway, down here in your stats, you have base pass shader, the amount of instructions, and then the vertex shader, the instructions. This is how complex your material is to calculate. So if you have like freaking 3,000 instructions in a material, you might have like very good material instancing, you might have like use custom data to make sure you don't have too many draw calls, all that kind of cool stuff. But then if your material itself has a lot of instructions, that's still going to cost like quite a lot of GPU power. It's always a balancing scale between memory, instructions, and draw calls. So sometimes you want to have like a little bit more instructions to be able to take care of things with less draw calls. Sometimes you're like, maybe a couple more draw calls is fine if it means that I don't have to add like 500 more instructions to my material. That's just something that needed to be mentioned at some point, and I'm definitely not going to be making a separate video on. So there is that. So that's the texture variation now. There's not that much to it. I just wanted to show you, hey, this exists and it is very useful to be able to use. Next time, we're going to be looking at another very useful node that I just want you to know exists, because it's going to save you a lot of headache at some point in your life, I'm sure. And then we'll have finished the entire material course and we can move on to something a little bit more exciting again. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,